Good day, everyone. Our study is entitled Analysis of Unmanned Aerial Vehicle Acquired Spectral Images of Treated and Untreated Lakatan Banana. The authors are Arian Justin and Verga, Dr. Rancivel Marian Rojas Villanueva, and Professor Nelio Altaveros from the Institute of Mathematical Sciences and Physics, and Glyza Garcia and Dr. Edna Aguilar from the Institute of Crop Science. This study is part of the undergraduate thesis of Ms. Justin and Verga. The abstract reads, multispectral images of Lakatan bananas were captured monthly through unmanned aerial vehicle-based remote sensing. Reflectance from near-infrared and red bands were used to compute for the normalized difference vegetation indices of Lakatan that were supplied with different levels of fertilizer treatment. An image processing program was developed in MATLAB to analyze the spectral images and generate NDVI maps. After statistical analysis, results showed that observed changes in the NDVI over time were not significantly affected by the amount of fertilizer treatment supplied to bananas. Relationship between leaf area index and NDVI was also examined, and studies showed that the indices were moderately positively correlated to each other. Bananas are widely grown because these are highly demanded both in export and domestic consumption. The Philippines is one of the major producers and exporters of bananas globally, with the varieties Cavendish, Cordaba, and Lakatan. Lakatan is the most consumed variety of banana in the domestic market. Unfortunately, banana production continues to drop yearly due to poor utilization of fertilizers and poor cultural management by farmers. In crop cultivation, nutrient supplication, irrigation, and herbicide or pesticide application are generally required to improve the quality of crops, and crops should be monitored constantly to maintain the health of the plants and to properly utilize farm inputs whenever or wherever needed. Farmers use manual monitoring systems involving in-field measurements and lab test analysis, which are tedious, time-consuming, and costly. Precision agriculture using remote sensing and multispectral imaging techniques have emerged throughout the years as an alternative system to improve crop productivity and farm profitability. Multispectral images contain data about spectral responses of objects, which can be used to compute for vegetation indices such as NDVI. Spectral images were usually acquired from satellite-based sensors, but this platform is not time-flexible and disadvantageous for small-scale field monitoring. Hence, researchers were motivated to use UAV instead to acquire images for spectral analysis. In this study, we analyzed the spectral aerial images of treated and untreated Lakatan banana. We compare monthly NDVI values and examine the relationship between NDVI and leaf area index of the Lakatan subsamples. This is the flowchart of the methodology that I will discuss in detail. Here's the experimental layout of the study. T sub 0 refers to no fertilizer application, T sub 1 refers to 50% of recommended fertilizer rate, and T sub 2 refers to 100% of recommended fertilizer rate. The treatment started 2 weeks after the transplantation, which was on September 11, 2018, and were supplied monthly. Aerial images were acquired using a Tetracam MCA-6 multispectral camera attached to a hexacopter drone flown 80 meters above the ground. Image capture was done monthly from October 2018 to August 2019. A MATLAB interface was developed to analyze the images. The raw images were first imported and saved as TIFF images. The images were then filtered to separate the banana plants from the background. The images were then calibrated by highlighting the bare soil, and the calculated values were adjusted so that 0 NDVI refers to soil. The NDVI was calculated by dividing the difference of the NIR and red bands and dividing it by the sum of the NIR and red bands. Point 6 to point 1 are high NDVI values and corresponds to healthy or dense vegetation and appears green in the NDVI maps. Point 2 to point 5 are moderately high NDVI values and may correspond to shrubs, grasslands, or growing plants. It appears yellow or yellowish in NDVI maps. Values less than zero point 0.1 correspond to soil, withering plants, or other non-vegetative objects in the image. It appears red in the NDVI maps. Here are the NDVI images of Lakatan from October 2018 to August 2019. To determine whether or not differences and changes in NDVI values of Lakatan subsamples resulted from interaction between treatment level and time, mixed ANOVA for repeated measures was conducted. Mixed ANOVA is divided into two tests: test of within subjects effects and test of between subjects effects. In order for ANOVA results to be valid, data sphericity and error variance should be first considered. From testing, it was found out that data sphericity cannot be assumed, and because of this, Heinfeld adjusted values were considered. The interaction factor is not statistically significant at 95% confidence interval, so we can say that no interaction could be demonstrated between treatment levels and time. Time has statistically high significant effect to NDVI values of Lakatan bananas. There were significant changes in NDVI value across the whole sample over time regardless of the treatment supplied. Bonferroni paired t-test was used to determine if there is a significant difference between NDVI values month after month regardless of treatment supplied to the subsamples. From the result, it can be observed that all monthly NDVI changes were highly significant, except for the transition from February to March and from July to August. The differences of NDVI values for different treatment groups averaged across all time points are not statistically significant. At almost all time points, differences in NDVI values between treatment groups are not significant. These are also parallel with individual one-way ANOVA test results for each month. And then for the relationship of NDVI and leaf area index, they follow the same trend and are linearly correlated. However, for time point 1, this trend was not observed. Time point 1 was on October 2018, where canopy size are relatively small, onto which NDVI saturates because of greater soil reflectance effects. Time points 9 and 10 were on July and August 2019, where highest LAIs were measured, which means leaf cover are denser. For T sub 0 with no fertilizer application, there is a weak positive linear NDVI LAI correlation. For T sub 1 with 50% of recommended fertilizer rate and T sub 2 with 100% of recommended fertilizer rate, there is moderate positive linear NDVI LAI correlation. Although NDVI and LAI almost follow the same trend and are linearly correlated, the trend is not exponential as observed in researches such as that of Hoffman and Blomberg and Goswami et al. As a summary, spectral responses of treated and untreated Lakatan bananas were collected and recorded using a spectral camera mounted on an unmanned aerial vehicle. Lakatan subsamples were divided into 3 groups according to the treatment they received. Monthly spectral images were acquired from October 2018 to August 2019. Red and NIR reflectance were recorded and used to compute for the normalized difference vegetation index of the Lakatan. Monthly leaf area index was also determined from manual in-field measurements on same time period. No trend was observed from the monthly mean NDVIs, which were possibly due to weather factors, variations in number of suckers, and nutrition depletion due to presence of weeds and other stressors. LAI and NDVI follow the same trend except from the first month and for months with high LAI. This is attributed to the sensitivity of NDVI to soil reflectance and vegetation density. For treated Lakatan, there is a moderate positive linear NDVI-LAI correlation. As an extension to this work, we plan to monitor critical growth stages that will be useful in improving crop management. Extend monitoring to the fruiting stage of Lakatan to determine if the treatments will have significant effect on the NDVI of Lakatan past vegetative stage. Other varieties of bananas can also be considered, and effect of watering system, soil absorption, biomass, chlorophyll, and nitrogen contents can also be explored. These are some of our references. That ends my presentation. Thank you for your attention.